The gliders, also known as sailplanes, are a kind of aircraft that differ from the rest by their ability to fly great distances without the need of an engine or propulsion of any kind, even gaining altitude during their flight. But how is this possible? That's what I'm going to answer today in this video. Welcome to Joy Planes RC2. Personally, gliders are my favorite aircraft because they don't need an engine to fly, and because of the long, impressive wingspan they have. But their long wings have a reason to be. Let's start with the basics. We know that an airplane can fly or glide without an engine, but in the process, it will gradually lose altitude, and depending on its weight, aerodynamics, and other physical facts, it can go down faster. This happens to every airplane, regardless whether they are gliders or not. Without an engine, it is possible to fly for some distance and land as long as a constant speed and descent rate is maintained to be stable in flight. But the gliders are designed to take full advantage of this balance of forces. Gliders are made with lightweight materials, and the weight is distributed at strategic points in an efficient manner to improve air penetration. And the configuration of their wings allow them to have more lift with less aerodynamic drag. As a result, their glide ratio is one of the most efficient among all airplanes. The glide ratio is the distance that the aircraft can travel in respect to the lost altitude. For example, a Cessna 172 has a glide ratio of 9 or 9:1, which means that if its engine stops, it can fly from 100 meters of height for about 900 horizontal meters. In modern gliders, this gliding ratio can be between 40:1 to 70:1, which means that if a glider has a 50:1 glide ratio, then it could fly for 50 kilometers if it starts flying from 1 kilometer high, making it capable of covering long distances in this way. Still, it is impossible to gain altitude for an aircraft that moves through a static atmosphere without the use of propulsion of some kind. Luckily, our atmosphere is not static at all. To gain altitude, gliders can take advantage of various atmospheric phenomena. There are three main phenomena: the ridge lift, thermals, and wave lift. Thermals are the most common mentioned way to gain altitude in a glider. These are columns of hot air that are generated by the surface heated by the sun. This air becomes less dense than the surrounding air and begins to rise rapidly. The glider, when entering a thermal, can begin to fly in a circular pattern to stay inside it and gain altitude until the thermal disappears or weakens. The other way to gain altitude is with a ridge lift. These are ascending currents of air on the slopes of the mountains. It's simply air that is forced to climb a mountain, and a glider can take advantage of this current to gain altitude. The closer to the slope, the stronger the climbing rate. The last kind of lift is the wave lift. It's about using the waves generated after the air passes through the mountain. These waves extend for several kilometers and are invisible waves similar to the waves on the sea. Using these strategies to gain altitude, a glider can stay in flight for many hours. This is totally free and clean energy that glider pilots gather and manage to get the most out of it. However, to make the glider take off, you will need an airplane that will tow it to an acceptable altitude where the glider can start by itself. Another way to take off is with a tow winch from the ground. But the altitude gained in this method is not as much as the first method. Hopefully, in a sunny day, the glider can take thermals and fly longer. Other ways to take off in a glider is from the mountains, with a system of elastic ropes on a hillside, or by having a retractable propulsion system integrated into the glider that is only used to take off or gain altitude when needed. Why long and thin wings? The thin wings generate less aerodynamic drag than the common wings that are seen in self-propelled airplanes. In this way, the glider can pass through the air with less difficulty, obtaining the same lift and losing less speed than other airplanes. Another factor that helps for better aerodynamics is the design of the fuselage, making everything as smooth, thin and aerodynamic as possible, which is why the pilot enters the cockpit in much the same way as a Formula 1 driver in his car, almost lying down. The wings are also measured by aspect ratio. Glider wings have a high aspect ratio, and war airplane wings have a low aspect ratio. War or aerobatic aircraft wings generate more induced drag than the thin wings of gliders, but because they are short wings, they are more maneuverable. Maneuverability is a priority in warplanes rather than fuel efficiency. In the case of the gliders, it is not necessary to make quick maneuvers, so the priority is given to efficiency, sacrificing maneuverability. That's why the wings end up being naturally long, because the large wing area is required with the restriction of a reduced chord wing to minimize the drag. Gliders are built to be very light but strong at the same time. They are even so light that you have to put more weight on the wings to improve their penetration and speed characteristics. This is done by filling the glider with water ballast in special tanks inside the wings. The total weight of this ballast can be even higher than the pilot's weight. The water can be drained during the flight in case the thermals are not so strong, and must be also drained before every landing. In the beginning, gliders were made out of wood, with fabrics or metal, and then the use of composite materials like fiberglass, carbon fiber and Kevlar was introduced, achieving a very huge structural resistance with very light weight. Flight instruments. Gliders are equipped with the basic instruments that can be found on any other aircraft, except for the flight instruments associated with the use of an engine. The most used and necessary instruments are the anemometer, altimeter, variometer, and compass. You can also find a turn coordinator, sometimes an accelerometer, and tools like a radio and a GPS. One of the most basic indicators that are still used even in high-performance gliders is the yaw string. It is a small string, generally red, that is placed on the outside in front of the pilot, that indicates the wind direction in regarding to the glider flight. If the string is not centered, it must be corrected using the rudder, and that way the pilot makes sure that he is flying efficiently. Otherwise, that means that the fuselage is off the course by some degrees in respect to the airflow, and that generates a lot of drag. It is important to be aware of the speed of the glider at all times, since if the glider gets too slow than the recommended speed, it can lose some control and also get into a stall. Also, depending on the design, there is a specific speed in which the glider has a maximum efficiency between descent and distance traveled. To measure the speed at which the glider is going, in respect to the wind, the anemometer is used. The airspeed is different from the ground speed. The variometer indicates the speed of climb and descent. This instrument is super important to know when the glider is beginning to climb, usually when enters a thermal, and thus stay within the thermal. The gliders are equipped with a system that generates a sound depending on the speed of ascent or descent. With this sound, you can more easily identify if the glider is going up or down without having to look at the indicator at all times. As you have already seen in this video, gliders are a very interesting type of aircraft, especially because they don't burn any type of fuel to stay in flight. They only use the natural energy available in the air currents. Nowadays, gliders are used for sports and recreational purposes.